Let's take a look at this example. Okay, and again we are dealing with the parallel circuit. Are you seeing that? If not, let me redraw it. So this is my point A, for example, and this is my point B. Okay, so what I have over here, I have this is my point A, and point A is connected with three resistors, R1, R2, and R3. So this is my R1, this is my R2, and this is my R3. Okay. Now, I have positive 24. How am I supposed to look at this problem? Positive 24 means I have power supply, okay, voltage source connected in this way, okay, and I have negative 8 volts. It means I have another voltage source connected this way. Okay, it means that, you know, at the bottom I have connection with the negative terminal of my voltage source, okay, and the ground is between these two voltage sources. This is my ground. Okay, so next you're supposed to realize that this is voltage source 1, which is 24 volts 1, and this is voltage source 2, this is 8 volts. Okay, so we got this circuit. So this is the way how the circuit is supposed to look like when this is built. Okay, so the engineers use the shortcuts, that's why they write like 24 and negative 8, but it simply means this circuit. Okay, so we have, this is our point A, this is point B. We're supposed to find the voltage across these resistors. Okay, we have two voltage sources and we have to find the voltage across these two resistors. So we have to, other words, find the voltage AB. So let's write this, V total, or we can say this is VAB. Okay, voltage between these 2 points. This is nothing else just VA minus VB. Okay, where VA is the voltage over here, right? This one, right? 24 volts minus, and at B I have negative 8. So this is negative 8 volts. So I have 24 volts, negative times negative is positive 8 volts. This is equal 32 volts. Okay, so this is voltage across the resistors. Next, I'm supposed to find the current which goes through resistor R2. Okay, so I can say that, you know, this is parallel circuit, so V total is equal to V R1, this is also V R2, this is also V R3, okay, and this is equal 32 volts. So if I want to find IR2, I simply use Ohm's law and write V R2 over R2. And this is equal 32 volts divided by 8 ohms. Okay, this is equal 4 amps. Okay, so this is the current which goes through resistor R2. Next, we're supposed to find the total current. Okay, we're supposed to find the total current in this circuit. So in order to find the total current in this circuit, I'm going to find the total resistance. Okay, and I have 3 resistors. That's why I'm going to use the following formula. R total is equal 1 divided by, open parenthesis, 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is equal 1 divided by, open parenthesis, 1 divided by R1, which is equal 12 ohms, plus 1 divided by 8 ohms, plus 1 divided by 4 ohms. Okay, so this is equal 1 divided by open parenthesis 1 divided by 12 plus 1 divided by 8 plus 1 divided by 4 close parenthesis equals 2.18 ohms. So this is the total resistance of my circuit. Next I'm supposed to find I total. I'm going to use Ohm's law. I total is equal V total over R total. My V total is equal 32 volts. So I have 32 volts divided by R total, which is equal 2.18 ohms. So I have 32 divided by 2.18. This is equal 14.67 amps. 14.67 amps. Okay, this is my I total. Next, I'm supposed to find the power at resistor R3. So P3 is equal to VR3 to the second power over R3. So this is equal 32 volts to the second power over 4 ohms. Okay, so this is equal 32 to the second power divided by 4 equals 256 watts. 256 watts. Okay, so we found the total current. We found the current R2, current which goes through resistor R2, and we found the power at resistor P3. So we can say that the problem